The last thing to deal with respect to multiple regression is collinearity. And it's the problem when I have two or more independent variables. If any of those pairs of variables are highly correlated, it causes problems for the regression model. Essentially, the regression model collapses. So if we're looking for correlation, they don't necessarily have to be in the high 90s, as we'll see in a sec. We have to deal with that problem. Okay, so here's an example of what's going on. So variable y in this case will be grade from our example. X would be reading or math, and W would be reading. And what's happening here is that each variable, in terms of its unique contribution to the prediction of y or grade, is extremely slim. And the reason for that is variable x and w overlap so much. So once again, the circles are the total sums of squares or variance for the given variable. The overlap is the extent of correlation between those variables, or how much shared variance there is between the two. When I have two independent variables, two x and w, reading and math, predicting grade, my regression model essentially falls apart when I have just a sliver that is a unique contribution of, which is A, which is the unique contribution of reading, the prediction of grade, and D, which is the unique contribution of math to the prediction of grade. And my variances, everything becomes out of whack. My variances become inflated. All kinds of problems occur. Okay, to assess for collinearity, what I have is there's a couple of metrics that are available to us to assess with the multiple regression equation multicollinearity. I look for it by what's referred to as tolerances, or what's referred to as a variance inflation factor. So a tolerance is a metric of collinearity. As it approaches or gets close to a value of 0, I'm becoming more and more concerned about my collinearity problem. The cutoff, as I know, it's just a subjective cutoff, but if I have a tolerance less than 0.2 for a given variable or pairs of variables, then I know that I have a collinearity problem in terms of that pair of variables or predictors. The other is the variance inflation factor, and for the variance inflation factor, my kind of like subjective cutoff is a value greater than 4. So if the tolerance is less than 0.2 and the variance inflation factor is greater than 4, but that combination, or one of those being high and the other one not, I have to start looking to see, do I have a collinearity problem? So we have our data, which is our reading table. X1 is my dependent measured grade. Math is my X2, which is the independent variable predicting grade, and then reading as a independent variable predicting grade also. So to complete my analysis of my collinearity assessment, I go to my regression linear. I have grade as my dependent measure and math and reading as my independent measures, and I want statistics. So the statistics I want my model fit, but I can get the part and partial correlations, and I can get my collinearity diagnostics. So I can click those on. I go continue, and then I'll go to my output. Okay, got an R squared here, so that's what we've seen before. We've done this calculation. My slope functions. Partial and part correlation. The partial is always larger because it only looks at the remaining of y in terms of as a denominator, and my part correlation. So as we know, the zero order correlation between reading and grade is 0.67. It basically disappears as a part correlation or semi-partial correlation when I factor out the influence of math. Tolerance, if this is less than 0.2, I get concerned. If the variance inflation factor is greater than 4, I get concerned. So in this case, I have no real concerns. Okay. Let's look at the problem using a slightly different technique. Okay, what I can do is I can work, because we know how regression works, as long as I have the correlations, the means, and the standard deviations, I have all the information I need to complete regression analysis. And you can do this in SPSS. This isn't a requirement for the course. I'm only using it for to show an example. So I have this is basically our regression analysis with reading and math predicting grade. Here are the correlation coefficients rounded to umpteen decimals. My n, and I know I need my standard deviations and my means. I can run that same analysis that I just did using just the matrix data. Well, that didn't go well. That's better. Sorry about that. Glitch. This replicates what we saw before. Here's my previous analysis before my hiccup. So here's a previous analysis with the actual data in rows of individual subject data. Here's the analysis replicated using just the information from the correlation coefficients and the means and standard deviations. Okay. Now I can see that the correlation between x2 and x3 is 0.75. And I know from my analysis I don't have a collinearity problem. I can change that data and I up the correlation from here, 0.75, I up it to 0.91. So I've created a great deal of overlap between reading and math. And essentially the correlation is 0.91. 80% of the variability in math and reading can be explained by each other. So that's the shared variance between it. So they overlap a lot. So with that change and changing the data so the overlap between math and reading is great, or is increased, I can now rerun the regression analysis having just changed that one value, changing the correlation between reading and math. And when I run that, I'm going to go to my output. Okay, so this is the new data. Here's that correlation of 0.91 between math and reading. My R squared now is 0.97, whereas before the R squared was 0.83. So just by that one change, increase in the relationship between the two has increased my R squared up to 0.97. My model F observed is now 183. My tolerance here is 0.172. That is now less than 0.2. That red flags me that I have a collinearity problem between math and reading as a predictor of grade. My variance inflation factor is now greater than 4, up to 5.82. So I have a problem with this analysis. Basically, math and reading are fighting with each other to predict grade, and there's no real winner here. So there's basically, what do I do with it? The simplest solution is to eliminate one of the variables, point out the best idea. The other solution is to run factor analysis. So if I can run factor analysis, create factor scores, and for the given two variables per person, I can then use the factor scores, which would basically take math and reading and combine them into one measure or one score. That's probably your best option, and that's what I would recommend doing, but that is well beyond what we do in the course. And that is it for collinearity.